Dear students, this is lecture number 2 of module 2, that is boiler problems and softening methods. And in this video we are going to discuss about boiler corrosion and caustic embrittlement. Boiler corrosion. We will discuss its definition, causes of boiler corrosion, disadvantages of boiler corrosion and prevention of boiler corrosion. Here we can see the picture of boiler tubes affected with corrosion. Now the definition of boiler corrosion. Boiler corrosion is the decay of boiler material either by chemical or electrochemical attack of its environment. Corrosion in boiler is due to the presence of dissolved oxygen, dissolved carbon dioxide and mineral acids. So the first cause is dissolved oxygen. The presence of dissolved oxygen is responsible for corrosion in boilers. Water containing dissolved oxygen, when heated with boiler, then free oxygen is evolved, which corrodes boiler material as iron is the boiler material and water with dissolved oxygen. So the reaction between iron and its environment, that is water and dissolved oxygen, forms ferrous hydroxide. This ferrous hydroxide again reacts with dissolved oxygen and forms rust, that is ferric hydroxide. Now removal of dissolved oxygen. First is chemical method. By adding calculated amount of sodium sulfide or hydrazine or sodium sulfide, we can remove dissolved oxygen from water. So reaction between sodium sulfide and oxygen, it gives sodium sulfate in PPT form. Now the reaction between hydrazine and oxygen, it gives nitrogen. Nitrogen escapes out from the boiler water. Now the reaction between sodium sulfide and dissolved oxygen, it forms sodium sulfate. So this is the chemical method to remove dissolved oxygen from water. Now second method is mechanical deaeration. Here we can see the mechanical deaerator. In this process, water is sprayed into a tower fitted with perforated plates, heated from sides and connected to vacuum pump. High temperature, low pressure and large exposed surface area reduces the dissolved oxygen in water. Here we can see a tower in which perforated plates are fitted. Perforated plates means plates with holes. In this tower, we have conditions like high temperature and low pressure, and this tower is heated from sides and connected to a vacuum pump. Conditions like high temperature, low pressure and large exposed surface area, when water is passed from these perforated plates and these conditions, we get deaerated water. Deaerated means removal of all types of gases present in water. Now second cause is dissolved carbon dioxide. When water containing bicarbonate is heated, carbon dioxide is evolved, which makes the water acidic. Carbon dioxide dissolved in water forms carbonic acid and leads to the intense corrosion on boiler metal. Here we can see the reaction between carbon dioxide and water. It forms carbonic acid. It forms carbonic acid. So when magnesium bicarbonate decomposes, it gives carbon dioxide and leads to the corrosion of boiler metal. Now removal of dissolved carbon dioxide. Chemical method means addition of calculated amount of ammonium hydroxide. It forms ammonium carbonate after the reaction with carbon dioxide. Now second method is mechanical deaeration process along with oxygen as described earlier. And filtering water through limestone. Calcium carbonate is known as limestone. When water is filtering through limestone, it forms calcium bicarbonate. But this method increases hardness of water. It increases temporary hardness of water. Now third cause is presence of mineral acids. When water containing magnesium chloride is used in a boiler, then hydrochloric acid is produced. This hydrochloric acid attacks the boiler in a chain-like reaction, producing hydrochloric acid again and again, which corrodes boiler severely. Here we can see magnesium chloride present in water forms magnesium hydroxide and HCl. This hydrochloric acid, this liberated hydrochloric acid reacts with iron material of the boiler in chain-like process and producing HCl again and again. The liberated acid reacts with iron material of the boiler to form ferrous hydroxide. Ferrous hydroxide turns into rust in the following way. When ferrous hydroxide reacts with oxygen, it forms rust. Means we can say the presence of even a small amount of magnesium chloride will cause corrosion to a large extent and may cause damage to the boiler material. Now removal of acid. Chemical treatment. We can do chemical treatment, frequent blowdown operation, chemical treatment or addition of inhibitors like sodium silicate, sodium phosphate, sodium chromate, which protects the boiler material against acid attack. By the use of soft water. If we add calculated quantity of alkali from outside, this alkali neutralizes the acid for prevent the corrosion. Now disadvantages of boiler corrosion. Boiler corrosion बॉयलर की लाइफ को शॉर्ट करता है, लीकेज करता है जॉइंट्स एंड रिवेट्स में, रिपेयर कॉस्ट और मेंटेनेंस कॉस्ट को इंक्रीज कर देता है. Now caustic embrittlement. We will discuss its definition, causes, disadvantages and prevention. And this is the picture of caustic embrittlement in boiler. Definition of caustic embrittlement. The phenomenon in which the material of a boiler becomes brittle due to the accumulation of caustic substances. That means caustic substances or presence of caustic substances are responsible to make brittle boiler material. Causes of caustic embrittlement. Presence of sodium carbonate, that means soda. As water evaporates in the boiler, concentration of sodium carbonate increases. When we use hard water in boiler, as water evaporates in the boiler, then concentration of sodium carbonate increases. Or when we use water, soft water by lime and soda process, so some of the sodium carbonate may left behind in the water. This sodium carbonate reacts with water and forms sodium hydroxide. And this sodium hydroxide is responsible for caustic embrittlement. This sodium hydroxide attacks the surrounding material and dissolves the iron of the boiler at sodium ferrate. This sodium ferrate decomposes and again gives NaOH, sodium hydroxide. And this sodium hydroxide is responsible to make the boiler metal brittle. Disadvantages of caustic embrittlement. This causes brittlement of boiler parts, particularly stressed part like bands and joints, etc., causing even failure of the boiler. Prevention of caustic embrittlement by using sodium phosphate instead of sodium carbonate as softening reagent. By adding tannin or lignin to boiler water, it blocks the hairline cracks and prevents infiltration of caustic salts into these areas. Adding sodium sulfate to boiler water, these also blocks hairline cracks.